Today we talked a little bit more about the discriminant, which is part of a polynomial, and it all depends on your coefficients. So we have to keep in mind that right now we are just using the standard form of a quadratic equation. So ax squared plus bx plus c. So our coefficients are still the most important part that we are working with. The actual definition of the discriminant is when using the quadratic equation, the discriminant is the part of the quadratic formula under the radical. So when we look at our quadratic equation, we have to think back. It's negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. Our discriminant is going to be the part under the radical. So our b squared minus 4 times a times c. That's the part that we are focusing on right now. And it might seem like kind of silly to just focus on one part of the equation, like why are we actually doing that? And the reason is because, sorry, my dog was distracting me. The reason is because it tells us how many solutions we are going to have. So we could have 2 real solutions of a quadratic. We could have 1 real solution, or we could have 0 real solutions. So looking at this first example, 2 real solutions. That means we have 2 x-intercepts, 2 solutions to our quadratic. This happens when our discriminant, which we're going to use d, is greater than 0. So it could be 1/2, it could be 1,000. As long as it's greater than 0, we are going to have 2 solutions. When we have 1 solution, 1 real solution, that is when our discriminant equals 0. So this b squared minus 4ac is going to give us a number. If that number is greater than 0, we have 2 real solutions. If this under the radical ends up being 0, we have 1 real solution. And finally, if our discriminant under the radical ends up being negative, that means we have 0 real solutions, because if you think about it, taking a root of a negative, specifically a square root of a negative, we're not going to have a real number as our solution. It's going to be imaginary. So our discriminant is less than 0. It could be negative 3/4, negative 10, negative 500. It doesn't matter. If it's negative, it is less than 0. So we're going to move on to 3 quick examples. Try to fix my camera. Our first example, 2x squared plus 3x plus 1. I've just got to keep thinking, what am I actually looking for? I'm not looking for my whole quadratic equation. I'm just looking for b squared minus 4ac. In this problem, my a is 2, my b is 3, and my c is 1. I could write those down if I want to just quickly remind myself. A is 2, b is 3, c is 1. Or I could just jump right in and start plugging these in. B squared is 3 squared minus 4 times a, which is 2, times c, which is 1. Solving this, we get 9 minus 4, negative 4 times 2 is negative 8 times 1, negative 8. 9 minus 8, or 9 plus negative 8. Our answer is 1. That means our discriminant is greater than 0. 1 is greater than 0. So what I would write for my answer here, discriminant is greater than 0. And this tells me I have, 2 real, and I'll just write SOL for solutions. All right, next example. Number 2, x squared plus 2x plus 1. Again, we could remind ourselves and write a is 1, b is 2, c is 1. Or we could just jump right in and start plugging this in. B squared is 2 squared minus 4 times a is 1 times c is 1. This becomes 2 squared is 4, minus 4 times 1 is 4. Our answer is 0. This means our discriminant equals 0. This only happens, d equals 0, only if you get a 0 for your discriminant. If it's 1/2, that is still greater than 0. If it is negative 1/2, it is still less than 0. So this means we have one real solution, and that R just means real. Moving on to our final example, 2x squared minus 2x plus 1. Again, why not? A is 2, B is negative 2, C is 1. Plug this in. B squared is negative 2 squared minus 4 times 2, which is A, times C, which is 1. Negative 2 squared is negative 2 times negative 2. So we have 4, positive. Minus 4 times 2 is 8 times 1. So 4 minus 8. Our answer, negative 4. That means our discriminant is less than 0. It is a negative number. We would be taking the square root of negative 4. So we're going to get some imaginary numbers there. That means we have 0 real solutions. And that's it. The discriminant really just helps us see how many solutions we have. It's also a really great way to just quickly check what my answers are, like that I'm looking for, are going to be. We're going to use it more in the future, but these are the basics of what the discriminant is.